Okay, just a real quick overview of the 3 worksheets. The first one is all about solving algebraically, so there's going to be algebra involved. Most of it's going to deal with factoring if you can't use substitution. So in all of these, first look to see, can I substitute? So this is the limit as x approaches 3 of this rational function. Now there's a vertical asymptote at x equals 4, but that's not what it's asking for. It doesn't say what's the limit as x approaches 4, it says as x approaches 3. So if you can use substitution, you have to show that step, that you're going to substitute in the 3, and then give the answer. So by substitution, all you're doing is substituting that value in. You only can do that if you don't get it undefined. So this would be what, 7 over negative 1. So negative 7. Okay? You may have to do some things like with number 2, where it says the limit as x approaches 2. Now at 2 there's a vertical asymptote or a hole. Something's going on because it's undefined at 2. I cannot substitute 2 in because I get a 0 in the denominator. So then you have to do some algebra. So before you do the algebra, you haven't evaluated the limit. So you're still going to say the limit as x approaches 2 of factor the numerator. I believe it factors into x minus 2, x plus 3. And then I see that this x minus 2 cancels. So from our work with rational functions, we should know there's a hole in the graph. So this is equivalent to the limit as x approaches 2 of x plus 3. So these two equations, these two functions, look the same, except for this one has a hole when x is 2, this one does not. It's linear. So now I can do substitution because all I'm dealing with is the limit. So I substitute in a 2, I have to show that substitution step, and then I get an answer of 5. So algebraically, as you're doing, before you evaluate the limits, as you're doing the algebra, you have to still say it's the limit as x approaches 2 of this function, which is the limit as x approaches 2 of this function. Then I can use my substitution to get my answer. And most of these are pretty similar to that you have to do some factoring. If you can't use substitution, you'll have to do some factoring so something cancels out. All right, everything on the back is similar to that. I'll let you try the factoring piece. If you get stuck, look at my answer key. So there'll be some factoring by groupings, there'll be the sum of cubes. You'll have to decide maybe how to factor this. You might have to use synthetic division. Here's a complex fraction. How do you simplify a complex fraction before you get started? Here you'll have to be adding the fractions together. So, there's a lot of algebra involved with those, but again, do the algebra until you can get to that step where you use substitution, and then you can substitute your value. Okay, so that's worksheet 1. Worksheet 2. A lot of these have to do with radicals. And one of the tricks, again, you first want to see if you can substitute in, and you can. If you can't substitute and you're dealing with a radical, one trick is to take and multiply by the conjugate of either the numerator or denominator, wherever that radical is. So in this one, I would multiply by the square root of 1 plus h plus 1. It's just the same two terms, but with a plus sign. And whatever I do to the numerator, I have to do to the denominator. Okay, so in the numerator, you're going to kind of FOIL those two things out because they're conjugates of each other. And so I'm going to get the limit as h approaches 0 of, when I multiply the first terms together, I get 1 plus h. The inner and outer product will go away, and I get minus 1. Now in the denominator, I wouldn't distribute that h. I would leave it as h times square root of 1 plus h plus 1. And you'll see something happens. 1 minus 1, that goes away. So I'm really left with the limit as h approaches 0 of h over h times square root of 1 plus h plus 1. So I simplify that. And now I see that the h's will cancel. And so I'm left with the limit as h approaches 0 of 1 over the square root of 1 plus h plus 1. And again, all of this is algebra steps to simplify what you're taking the limit of. You have not taken the limit yet, so that's why you still have to have the limit as h approaches 0. And now I'm going to use substitution. And I'll substitute in the 0, and I get 1 over 1 plus 1, I get 1/2. Okay, and that's kind of the trick in most of these, is looking at trying to multiply by that conjugate, only if you can't use substitution. All right, on the back, there's some things to do with looking at coming from one-sided limits. So what you need to look at, let me look at number 8, it's a little simpler. This is a rational function, so we need to think about what we know about rational functions. So we first factor, and if something factors, remember there's a hole. Well, in this one, I can't plug in the 1, nothing factors, so I know it's a vertical asymptote. So now what we need to do to look at the limit as x approaches 1 from the positive side, one of the ways to show your work on that is to graph it. So I know there's a vertical asymptote at x equals 1. And so I'm really looking at what happens coming from the positive side. So is it going to infinity or is it going to negative infinity? And so to do that, we can plug numbers in. Now you don't want to show that anywhere because they really aren't using substitution. But you're saying, okay, let's put in 1.1. So we're going to come this way and get close to 1, but on the positive side. So if I put in a 1.1, 2 times 1.1 is 2.2 minus 7. That's going to be negative. So all I need to worry about is that that's negative over, when I put in 1.1 here, 1.1 minus 1, I get a positive. So I know that when I'm on the right side of 1, that fraction is going to be negative. So it's going to come down towards negative infinity. Now, when you graph it, you really should probably graph the entire thing correctly. So when I look at that, I also know there's a horizontal asymptote at 2. Remember, the degrees are the same. So there's a horizontal asymptote at y equals 2. And so this is coming down this way. I could find the intercepts. When I set the function equal to 0, I would get 2x minus 7 equals 0, so that would be at 3.5. It's going to have an x-intercept, which makes sense, so it's going to come out that way. It also has a y-intercept of 7, so that's clear up here, and it's going to go in that direction. So that's kind of the graph of it. So one way to show your work on this, you can't really use substitution, but you can show your work that, okay, the limit as x approaches 1 coming from the positive side is negative infinity. So if you have a vertical asymptote and you're looking at the limit as x approaches that vertical asymptote, you're either going to say an answer of negative infinity or positive infinity, or if this question was what's the limit as x approaches 1, we'd have to say doesn't exist because it goes to 2 different places. Okay, but one-sided, we can answer that question. This one, we need to make sure you know what the graph of that looks like. It really looks like x over x when x is positive. So it's going to look like 1 when you've got positive values of x. It's undefined at 0. So when you put in like 2 and 3 and 4, the absolute value of those numbers divided by itself is just 1. When x is negative, like negative 1, negative 2, you're going to take 1 divided by negative 1, 2 divided by negative 2, you're going to get negative 1. So you need to know the graph of this absolute value of x over x looks like this. So again, the work to that is just show the graph. Limit as x approaches 0 coming from the negative side is negative 1. So the work, I don't really need to see algebra on that one. That would be something graphically you could show and prove. Then the piecewise, just real quick on piecewise. When you're looking at piecewise, remember you're looking at coming from both directions. So when this says what's the limit as x approaches 5, I'm not looking at what happens when x equals 5. I don't care about what happens when x equals 5. I want to know what's the limit as x approaches 5. So this says everywhere else on the graph, it's going to follow this curve. So I'm really then going to look at the limit as x approaches 5 of x squared minus 9x minus 5. I don't have that is coming from both sides. So does that factor, because I can't put in a 5, x minus 5, no, x minus, no, it does not factor. So since it doesn't factor, again, that's a vertical asymptote. So now I have to say, okay, if that's a vertical asymptote, what happens as I come from the left side, and what happens to that as I come from the right side? So, you first look at it and say, okay, I'm looking at the limit as x approaches 5 of this piece. If this could have been factored, then I might have had a hole in the graph and I would have had a limit right away. It doesn't factor. So now I have to look at coming from the negative side and coming from the positive side because that's a vertical asymptote. So let's draw a picture of the graph. Here's 5. This has an oblique asymptote, so it's going to be getting bigger as x increases, so I really don't have a horizontal asymptote, but I can look at, okay, let's put in numbers a little bit smaller than 5, so like 4.9, and it's a little bit harder up here to figure that out. You may, probably faster if you use your calculator, even though you still could do it without a calculator, but if I put in 4.9 and square it, minus 9 times 4.9 minus 5, you're going to get a negative. And again, we probably could have figured that out without doing too much math, but it's going to be a negative number. And if I put in a number a little bit smaller than 5, I'm going to get a negative, so that's going to be a positive. That's going to go to positive infinity. And then down here, if I put a number a little bit bigger than 5, like 5.1, again, if I square that, but I am subtracting 9 times that, so that becomes the issue. And then subtracting another 5, that's also negative. It makes sense that that would still be negative. And then something bigger than 5, that's going to be positive. So that's going to go to negative infinity. So what's the limit as x approaches 5? Well, if coming from the negative side and coming from the positive side, it's going to two different spots. So now I need to say this limit does not exist. Okay? Now with this one, you're going to have to look at the limit as x approaches. If it said the limit as x approaches 3, you'd have to go coming from the right when x is less, or coming from the left when x is less than 3, and coming from the right when x is greater than 3. So you'd actually have to look at both. This says coming from the left, so it's numbers that are smaller than 3. So now I'm going to look at that limit. It's going to be the limit as x approaches 3 of 2x minus 4. And I can use substitution to get that answer. And I would get 2. Okay, so that is kind of the limits piecewise. Limits if you're looking at a vertical asymptote, and then limits if you're dealing with radicals.